Hi. So today we're doing CPM IM2 section 5.1.1, the beginning of chapter 5. And that means it's the beginning of our study of parabolas. This is easily one of the two most important topics in all of IM2, the other being trigonometry. Our goals today are twofold. First, we can use the equation of a parabola to calculate y values for a XY table, and then use the results to plot points and graph the corresponding parabola. The second is just as important, but much more short. We can label key features of a parabola. Okay, sorry that that's not that tidy, but you'll get used to it. Anyway, your team will be assigned to specific quadratic functions. Your team will be assigned specific quadratic functions to study. You investigate the function, use their tables, graphs, and equations to describe them completely. If you're in class, you only have to do one of these. If you're at home, you only have to do one of these, but I'm going to do all 10 for those of you who are watching this video. If you're watching the video, you have to do one of the following 10 pages that I'm going to produce, as well as a graphic organizer, which is at the very end, where we have a couple examples. Okay, first, we're going to choose one of these. Here's one, x squared minus 2x minus 8. That's what y equals. This is the equation of a parabola. Y equals x squared minus 2x minus 8. And then I'm going to complete a table of values. So I'm going to start with negative values and then do positive values. Let's see. I'll start, I think, with -4, and I'll go up to +4. So when x is -4, to find y, I take -4 and I plug it into my equation. So I have -4 squared minus 2 times -4 minus 8, which gets me 16 plus 8 minus 8, which is just 16. I take that point, 4, 16. -4, 16, and I plot it. So x is -4, that's right here, and y is +16. First point has been plotted. Yay. Okay, I'll do -3. That's -3 squared minus 2 times -3 minus 8. I'm getting that from up here, plugging -3 in for x. That's 9 plus 6 minus 8. 1 plus 6 is 7. So -3, 7 should be on my graph. I'll plot that. -3 up 7. Very good. Okay, -2. Oops, I think I'm running out of space. I will use a Post-it. For -2, I have -2 squared minus 2 times -2 minus 8, which is 4 plus 4 minus 8, and that's 0. So -2, 0 is on my graph. -2, 0. There we go. That's for -2. Take another Post-it. I'll do -1. So as always, I use my equation. I plug in my x value to where the x's were, and then I solve to find out what y must equal. So -1 is my x value. This is 1 plus 2 minus 8. That's 3 minus 8, which is -5. -1 comma -5 should be on my graph. -1, -5, right there. Okie dokie, let's do 0. Zero squared minus 2 times 0 minus 8. That's just going to be -8. 0 comma -8. Now we're going to see something happen, which is part of the lesson. A possible observation. Watch this. +1. So I'm going to do 1 squared minus 2 times 1 minus 8. And I have a prediction without doing any calculations. I think +1 is going to have an interesting result. Let's see. 1 minus 2 is -1, minus 8 is -9. Okay, is this going to be an important point? We'll see. 1, -9. Pay attention to this point right here. In fact, here's some really special points. Next, I'll do 2 squared minus 2 times 2 minus 8 is 4 minus 4 minus 8. That's -8. Interesting. Notice that these two are the same. I wonder if that's something that we can look to keep going. The point was 2, -8. Next, we'll do 3. 3 squared minus 2 times 3 minus 8. 9 minus 6 is 3. 3 minus 8 is -5. 3, -5 is the next plot to point. Over 3, -5. Interesting. That's a repeat too. Okay, next. I'm going to do 4. 4 squared minus 2 times 4 minus 8. That's 16 minus 8 minus 8. That gets you 0. Okay, that's the point 4 comma 0 over 4 up to 0. Look, that's a repeat value too. Huh.
Happy New Year.
Happy New Year. So the next point we're going to do is 5 comma. But I'm not even going to calculate this. I'm just going to take a wild risk and assume that my pattern continues. So I had 9 as my middle value, then down 3 to get to 0. I'm going to think it's going to be 7. Let's just see if it looks right. So over 5 up to 7. Let's see, right there. Wow, look at that. Cool. Okay. There's actually a really special word for this, and it's a word you've heard before. I'm connecting my points with a smooth curve. And the word is symmetry. All parabolas have symmetry. There's a lowest point or a highest point. The parabola could be turned upside down. And then all the other points appear on either side. So I've already graphed the function. So this question is done. I noticed that this were a cup, it would hold water. That means it opens up. Sometimes this is called concavity. We would call it concave up. The vertex, this is the lowest or highest point. And our vertex is right here We can just call it V, and it is at 1, -9. This is the special point because all of the other points are mirrored around it. 1, -9. It's the lowest point. Our x-intercepts. We've found x-intercepts and y-intercepts before, not as a class in IM2, but you did it in IM1 and hopefully in previous classes before that as well. Our x-intercepts are where our graph crosses the x-axis. Here's my x-axis. My x-intercepts are where we cross. So we have one right here and another right here. Our x-intercepts are these 2 points. For parabolas, there can be 2 x-intercepts, 1 x-intercept, or no x-intercepts. Okay, so I've got an x-intercept at -2, -1, and I have an x-intercept at 4. Oh, did I say -2, -1? I'm so sorry, everybody. That should have been 0. I'm a little deep into this video to start from scratch, so just know I meant to write 2, 0. And here I have 4, -2, 0, 4, 0. These are where the parabola crosses the x-axis. Now the y-intercept. Similar to the x-intercept, the y-intercept is something that you've seen before. And it's where the graph crosses the y-axis. So here's my y-axis. And here is where my graph crosses it. Intersects. This is the point. 0, -8. Sometimes people will be tempted to make the y-axis the vertex. It's not. The lowest point for our parabola here is just a little bit lower. 0, -8. Where the parabola crosses the y-axis and the line of symmetry. Remember we talked about symmetry? Symmetry allowed us to see that we had repeating y values across the vertex. The line of symmetry is pretty easy to find once you have your vertex. All parabolas that we will do in this class are vertically oriented, meaning for this, we can take our x value from our vertex, and that's going to give us the value we need for our equation for the line of symmetry. The line of symmetry should be written as an equation. Here we are. It's this line right here. I'm going to draw it right onto the parabola. That's not very dark. I want a darker green. Right onto the parabola. Right here. That's our line of symmetry. And it's the line x equals 1. Line of symmetry. Sometimes students will write 1. That's a bit of an error. It's subtle, but there's a difference between the value 1 and the line x equals 1. This is the line x equals 1 because if you notice, every point on the line, if you were to write it as a coordinate, would have an x value of 1. So that's our first graph. There are several more. I'm going to turn the page. This is the one we've done. For now, because we might run out of time, I'm actually going to go to the features of quadratics, where we have 2 more. And I'm going to do example number 2. This is an important example because we'll have to figure out how to find this vertex, which is not on one of these points. Please watch. Here we go. So I'm going to solve for y by plugging in my x values. This is negative x squared plus 3 times x plus 4. That's the format I'm going to use for all of these. I plug in 0 for x. That's 0 plus 0 plus 4. So my y value is 4 and my point is 0, comma 4. For 1. Same setup. I plug 1 in. This is a place where many students will make a common error. 1 squared is the value, but you're not squaring -1. You're just squaring 1 and then taking that negative. So 1 squared is 1. Make that negative. You can come in. I'm just filming. I'm glad to see you. Plus 3 plus 4, which is in the end 2 plus 4, which is 6. And the point is 1, comma 6. Now for 2. Same setup. I plug in 2. This is -4 plus 6 plus 4, which is just 6. So I have the point 2, comma 6. Notice I already have a repeating y value. That means that somewhere in here, I'm going to have my symmetry. Okay, for 3. -3 squared plus 3 times 3 plus 4 is -9. Notice that all of my squared values are becoming negative. That's because the negative is not inside the parentheses. It's outside the parentheses. Anyway, -9 plus 9 plus 4. That's 0 plus 4, which is 4. So 3, comma 4 is on my graph. And we have this -4 squared plus 3 times 4 plus 4. This is going to be -16 plus 12 plus 4, which is 0. So the point 4, comma 0 is on my graph. Let's plot these points. Oh, look, it's done for us. Haha. Okay. I'm still going to plot them though. So over 0 up 4 is on the graph. 1, comma 6 is on the graph. 2, comma 6 is on the graph. 3, comma 4 is on the graph. 4, comma 0 is on the graph. If you had only plotted these pink points, you would have been able to find the other x-intercept using symmetry. So I would have known that if I had gone left 1 from here, I would have needed to go down 4 again, and that would have been my other x-intercept. That's because that's the pattern that happened on this side, and parabolas are symmetric. So you can mirror a pattern on either side. I'm going to circle the vertex because we have to think about it a little more, but for now we can fill out the rest. This opens down. Our first example opened up, this opens down. Our x-intercepts are -1, comma 0, and 4, comma 0. That's where my graph crosses the x-axis. My y-intercept is where my graph crosses the y-axis. In this case, it is 0, comma 4. My line of symmetry, I'm also going to pause on that. I could get it from this graph because it was already graphed for us, but I want you to know how to do it. So let's think about this. I know that I have a point at 1, 6 and 2, 6. I know that my vertex is in the middle of the graph. So to find the x value of my vertex, I could go between the values 1 and 2. This would be right between those values, 1.5. The x value of my vertex will be 1.5. And that also tells us where the line of symmetry is. This line of symmetry is at x equals 1.5. And I can find the vertex now because if I have an x value and an equation, I can find my y value. So here I have my x value, 1.5. I need to solve for y. And to do that, I do negative of 1.5 squared plus 3 times 1.5 plus 4. And if I plug that in, I get 6.25, which is the vertex. Okay, so the lesson today is how to plug in values for a parabola, find the points, graph them, and then find these key features. Hope you have a great day. Turn in your notes. Bye.